So we're back. It's hour 2 of week 3 of programming fundamentals, and we're just playing around with C#. One of the other things we should probably talk about is documenting a program. This is really important. I really can't overstate how important this is, and I'm going to do it in all the code we write, and actually in all your assignments there's marks for documentation. So there's 2 kinds of documentation going to worry about in this class, and that's doing external documentation. So typically when we build applications for people, we probably need to write some kind of manual or user guide so that people, every time they have a question or problem, they're not going to contact us, they can refer to the manual quickly and easily for help. Okay, we're not going to worry about external documentation, but what we are going to worry about is internal documentation, what's called internal documentation, simply known as comments. Okay? And when I give you assignments, the big assignments, actually a few of the marks are for putting comments in your code. Okay? So comments, there's a few different ways we can mark that something in our code is a comment. If we're doing a single line, we can just put in C# 2 slashes in front, and then we can put in a comment. If our comment is long, we start a comment here this way, and we end it this way. Now, why would we want to put comments in any program or web page that we're writing? Wilson? Okay, that's one reason. Yeah, it helps us organize our code.
Explains functions of formulas. For example, if someone else is editing your program later, and they don't know what they're getting numbers from, like, because variable X doesn't really seem that explanatory. You can actually explain what functions do, where numbers come from.
That's a great explanation. So many times we're working with web pages or code that other people have written, either because we're working together as a team on a large project, so we have to share files and work on things together, or because maybe we're working on a project that somebody else wrote a long time ago. Right? Next summer, you guys are going to be out looking for co-op jobs, and what do you think the chances are on your first day of co-op that your employer is going to say, here's a brand new project I want you to start from scratch. I have a brand new website and I want you to build it. What do you think the chances are of that happening? High or low? Probably low. They probably already have existing projects that have lots and lots of code in them. And those projects either haven't been finished, or they're finished, but maybe they need to be updated, or there are bugs in them that need to be fixed. So you're going to have to take on an application and code that somebody else has written. Well, it's it's infinitely harder to do if that programmer has never commented it. And in fact, I had this discussion with the second-year students. Many of them are on co-op, and I asked a lot of them, what was your biggest challenge while working? And the #1 answer I got was working on someone else's code where they didn't comment what it was doing. Writing the code, the hard part was trying to figure out what was going on. Okay. Not only are these comments useful for other developers, who else are the comments useful for? And Wilson, this kind of comes back to your point. Who are your comments probably going to help the most? Yourself, right? Because many of the applications we write, they're complicated. And we might write them today. I just got asked by a client who I built his website in 2006. And he's made small updates along the way. But think about how long ago that was, right? Technology's changed so much. And last year he had me do updates on that website. Well, to try and remember what the code I wrote 8-9 years ago, I don't even use that technology anymore. So the fact that there were comments in that code made it much easier for me to go back and change now. So we'll want to put comments, so a description of what's going on into our code. Okay. So we'll see how this looks. So what we typically want to do, so we're going to write this simple tax calculator. We'll put a couple of inputs on our screen in a minute. Here's all we want the page to do. We want to have one input, which is going to be some kind of numeric amount. Right? We simply want to calculate the amount of HST on that. What's the HST rate? 13%, right? And then we're going to want to display the amount of tax and then display the total. So we'll then add the tax to the subtotal and display those. So before we write any code, what we'll do is let's write out what the comments would be, what the instructions would be as to how our program is going to work. We'll write out all the steps, and then we can even draw it out with this little online drawing tool. We'll draw out a quick flow chart. We looked at them briefly last week. This is a really good way when we're starting out and try writing C# code. It's much more useful if we actually plan out what we're doing. We write out kind of a fake step-by-step version of what we're doing. We can draw it out visually, and then actually writing the C# is a lot easier. Just like we said last week, we don't want to builders showing up at your empty lot and designing and planning your house on the spot and building it on the spot. We want them to design it and plan it first and then show up with all the tools and build.
I don't know, it might be a little interesting.
It might be interesting. It's probably not a house I want to live in. Certainly wouldn't be one I'd want to pay for. So we'll just put our comments in right here. So I've created my tax calculator form. So if you don't have one, go ahead and create your tax calculator form. And again, I'll show you one more time. You just right click your project, choose add, and choose Windows form. And you can call it tax calculator. Visual Studio will build this blank screen for us. So now we have two forms in our project. So now I'm just going to click View and Code, and it'll take me into the code window, and it'll take me in here. So we're going to make comments as to what's going to happen. And notice when I put those two forward slashes in, Visual Studio, notice the color coding. In Visual Studio, when you see anything in green, that means it's a comment only, it's not active code. So it's a description of what's happening. So what's the first thing that's going to happen in this little program we're going to write? Let's think about inputs, processing, and outputs. Inputs are going to be first.
So someone types in how much they're buying, like
we want to give the user a way to enter an amount of their purchase. So we'll have one input and only one input. Okay, that'll be step one. There's our input. What will the next thing we need to do be? Once we have that input, what do we want to do next?
multiplied by the tax rate.
We said that rate will be, yeah. So if we multiply it by 1.3, that's 13%. That'll tell us how much HST is being charged.
And then add this purchase amount to the tax to have the subtotal.
Yep, so add. Yep. So that'll be the third thing. So now our program will know how much the actually in this case, sorry, it won't be the subtotal, that'll be the total. Right? So that's our processing. We're going to have to do two math operations. Calculate the amount of the tax, then take the amount of the tax and add that on to the purchase total. So now we come to the output part. How many outputs do we want in our program?
2.
Yeah, we'll have 2 outputs. What do those 2 outputs be?
Original price and the price of the tax.
Sorry, say that again?
Like original price and price including tax.
Okay, well, we're already going to have this. This is already going to display. So we'll already have the purchase amount from the input. It'll still be there. Okay, we will want to show the price after tax. What else might we want to show? Yeah, how much was the tax? So now we'll display tax and total. So that's what our program, those are our comments. And this is typically what we might actually add into Visual Studio, and we'll put those lines in green so that later on, if we have to go back and make changes, we have a clear understanding of what we're doing. And we haven't written any code, we're just planning it. We can actually draw this out for those of us who are visual learners. For some people, for me, this is really helpful. Before I write a complicated piece of code, I'm going to actually make all the comments first, figure out step by step, what's everything I have to do here? And then I can just do the tasks one at a time. But I've made all my decisions first, how this should work. If you open up any web browser, go to the website draw.io. The free tool that allows us to draw online. It's going to ask you where to save your diagrams. I'm just going to click on decide later. I'm not going to worry about saving my diagram for now. So we'll get a screen that looks like this. So there's a few symbols here. These are some basic flowchart symbols. And we're not going to use all of them. We're just going to use a few of them. So this one here, the third one in the first row that's an ellipse, we usually use that as a start symbol and a stop symbol. So I'll just click and hold this and drag it on to my screen. And I can just type the word, make this bigger. So we'll just grab a starting circle on here. Over here in the third row, we've got this parallelogram, the first item. These typically in flowcharts represent inputs or outputs. So I'll drag that on and type input purchase price. I can make it a little wider if I want, so it fits. And then I'll just click on this arrow and I can connect these two up. Well, click on this one single line arrow. Oops, no, maybe we'll do it a different way.
You can just click on start.
Yeah, actually, I can just click on start, and if I drag down, it generates an arrow. So there's my first step. My arrow's a little crooked. I'm not going to worry too much about it. So we're going to input the purchase price. Then I'm going to drag a rectangle on, which is for processing. We'll calculate tax. And then I'll just click from my input and drag down to calculate. I'll drag another rectangle underneath. For calculate total. And I'll connect those up. Then we want our, so we've done our input, we've done our processing. And then I'll drag one more parallelogram. As display X and total. I'll click and drag. End our process. So there's our flow chart. So really just a visual representation of our code comments. Now, eventually, after a while, we're not going to need to do this because we're going to be able to have enough experience to figure out how processes work and code them. We're still going to write comments. Even today, any application, any web page I build, I'm putting in comments as to what's going on in there. But this is a really useful tool as well when we're starting, when we're learning. And I will still use flowcharts when I have some kind of complicated process that I have to plan. Rather than sit down and write the code, I'll visually still map it all out. Here are all the decisions, all the different places that this web page could go, and all the different things that might happen. And I'll map out a visual plan using a tool like this. So I think I can actually save this.
You want us to submit this, or?
No, you don't have to submit this. This is just for you. I'll save this as an image. And I'll post my version on Blackboard, so you guys will have it as a reference, okay? So this is our so I'll put it up here.
Lego.
Yes, my daughter's selling her Lego. If anybody's interested, let me know. Okay, so that'll be on Blackboard. So we'll do this for a while. We'll plan. So these comments are also commonly known, I think we talked last week about it as pseudocode. It's not real code, kind of like plain everyday instructions that we can then take and use in order to actually write the real code. So now we've got this blank screen. We need to put on a few objects, a few controls, so that we can do the input and display the output, and also give the user a way to trigger our processing. So we're going to need our toolbox. My toolbox is gone. I can always get it back by clicking View and Toolbox. So what do we need on this form? I would suggest we need 4 things. Right? This is what we want to do. We need an input, we need a way to trigger some processing, and we've got 2 outputs. So what should we put on our form for the input? How are we going to get input from the user?
The first thing that's necessary would be to actually have text that tells the user what they're supposed to be doing.
Okay. So for the text, yeah, for that instruction, we can use one of these, the label that we used in our hello world. So let's drag a label on. And it says label 1. Down here in the properties, it says text label 1. So let's change this to say enter purchase amount. So I did that I change the text property of label 1 to say enter purchase amount, right? So there's some instructions. Okay. Now we need to give the user some way to give us the purchase amount. What should we give them?
Is there like an input option?
Sorry, you said it? Yeah, so down near the bottom, we have a text box. So there's tons of controls here. We're not going to use most of them. We're mostly going to use labels, text boxes, and there's a couple of others we'll use. Most of those we won't need. So I'm going to take a text box and I'm going to drag it up here. And notice once I have it aligned with my labels, see I get that blue line? That's telling me they're actually aligned. When I move it down, the blue line goes away. When I move it up. So it gets a name of text box 1. Later on, I probably want to make these things more descriptive. In fact, it's a good idea because if I have a whole bunch of text boxes, if they're called text box 1, text box 2, text box 3, it's going to be hard to know what each box means. I'm better off to give it a descriptive name. Could we call this? So notice in the properties sheet here, if I scroll right up to the top, it says by default the name here is text box 1. I want to name this something more descriptive. So what could we call this? Yeah, let's call it, we could maybe call it purchase amount. Okay, and here's one tip. Whenever we're naming things, we talked about this last week, we don't want to have any spaces. Okay? So I'll name it this way, purchase amount with no spaces. Or you could use an underscore. So now when we're referring to this box, we'll call it purchase amount, so we know what it is. Okay, so let's see how our form looks so far. If I run it, I can just press start. Okay. Well, our application's running. Why did we get the hello world screen?
We're running they're the same application.
Right, they're in the same project. By default, whatever the first form, by default, form 1 is going to be our default form. That's going to load first. So we want to change it. So now when we run our application, we want the tax calculator to load as our default form. So if we click on tax calculator, actually, let's see, sorry. So we need a way to tell our application to load our, okay. Right, so we have this is like a configuration file. So notice it says, so this program.cs, thank you. I knew it was in here somewhere. So this is, notice there's this main function, this is what starts our application. And if we look on line 19, it says application.run new form 1. So that's going to be the screen that loads by default. So if we don't want it to be form 1, we can just change that from form 1. And again, as soon as I type tax, my little comes up and I can just hit enter or with my mouse select tax calculator. So now tax calculator is the default form. And that's in this program.cs file. So if I press play now we don't see our hello world form anymore, we see our tax calculator. So we can type in the box and actually type anything we want. We won't worry about checking the input right now. We'll come to that another time. So I should have a label that says enter purchase amount and a text box. So I can type in a purchase amount here.
So now we just need a thing that will say the subtotal, not subtotal, the tax amount and the,
Yeah, so we have the inputs. We should give, but we need the user a way to trigger the processing. What should we put on our form next? Usually we'll put a button on, right? If it's a registration page, there's a register button. If it's a shopping cart, there's a checkout button. So we want to put a button on here that when the user clicks it, we can do our processing. Okay. So I can either hit stop. You can also just close the form. That also stops the application running and jumps us back to the code when we just close the form. So we'll go back to our calculator screen. And in my toolbox, I'll grab a button and I'll just drag it on here and align it with my text box. Now I can also make it bigger. I can drag it, or if I click on both of them, if I click my text box first and then my button, if I click format and make the same size and choose width, it automatically will align my button so it's the same size as my text box. Doesn't really matter what this looks like. We're not worried too much about the aesthetics of it. Notice my button by default says button 1.
the best name for it.
So in my property sheet, what should we call? Let's give it a description. We may have many buttons, so we don't want them called button 1, button 2, button 3. Every button should have a so what should we call this button that's descriptive?
Purchase amount button.
Well, it's going to trigger a function called calculate, so let's call it maybe calculate. So I give it a name of calculate. The text on the button, it still says button 1. Change this as well. So if I scroll down my button text, sorry, I click my button has a text property. So what should the instruction on that button say? So it makes sense to the user. Maybe we'll have it say calculate tax. Now this is just text, so I can leave a space. It's not the name of the button. The button is called calculate. Well, now I need to make it a little bigger. So I'll just make each of these a little bigger. I'll save that. So now this is where Visual Studio makes life easy for us. We have this button called calculate, and when the user clicks it, we want to trigger some processing, right? We want to calculate the tax and display our outputs. So in order to write code, we have a couple ways we could do it. We could go into our C# window, and we could, if we wanted to, we're not going to, but we could. We could write a calculate function ourselves, right? We could decide what inputs it needs and what it will return. But instead, Visual Studio makes this easier. We'll just go back to our design view. And if I double click the button, Visual Studio automatically writes a function. So it takes the name of the button and it writes a function called click. So this is what will happen when the user clicks the button. So we could write it ourselves, but why would we write that code when we could just click the button and let our code software do it for us? We won't worry too much about these right now. In a nutshell, this just means object sender. So what was the object on our screen that triggered this?
Maybe that library or something?
And were there any events or any information passed to it? In both our cases, we don't really need to be concerned about that. We also talked before, we looked at methods, we looked at, right, some methods. So our calculate shipping returned a decimal. Our submit payment returned a true or false, and our saved order and returned an integer. Here at Visual Studio wrote void. What do you suppose this means? What's being returned from this function? Nothing, right? Our function's going to do processing, but it doesn't send any values back. It just does the processing. So we'll make some comments in here. But the first thing we want to do, we've already done this, accept an input. So we'll calculate the tax. So we need to get the amount the user typed in purchase amount, and we need to multiply it by 0.13. And then we're going to want to store that tax amount. Here's where we're going to use a variable for the first time, right? We're going to calculate that amount, and we need to store it temporarily. So we want to create a variable to hold the amount of tax we're going to calculate. What data type should we use for the tax amount? A string, a date, a Boolean, a decimal, or an integer? Which one would make sense? Yeah, well, why would we need a decimal?
Because like there's cents.
Right, because there's a good chance we're going to have not a whole number. We're going to have dollars and cents. So we'll create a variable that's a decimal. We should give it a descriptive name. What do we want to call that variable? We could call it tax, or we could call it HST. Okay, so we're going to create a variable called tax. That's going to hold a decimal number. So now what value are we going to multiply by 0.13 in order to get that tax? Right, the number the user types in the text box, right? What did we call our text box? What's this text box called? Yeah, we called it purchase amount. So if I type PUR, again, my code editor gets rid of all the choices. I could actually just hit the dot, purchase amount dot. So here are all of the different properties and attributes. It'll tell us what the user typed in the box. It's not going to be the background color or the foreground color.
One that's highlighted right now.
Yeah, the one that's highlighted. It's actually making a suggestion for me. So I can just click with my mouse. So the amount of text the user entered in the text box times 0.13. And then I get a semicolon, right? So we're going to take whatever they typed in the box, we're going to multiply it times 0.13, and we're going to save the result into a spot in the computer memory, and that's called tax. But it's red.
Because the variable for the text is I believe string, and this is variable, decimal. So
You're absolutely right. Okay. If I put my mouse over it, we can see what the problem is. Our code's not actually wrong, but it's just not complete. It says you can't do multiplication because this number, it's considering what's called a double. So it's just another version of a decimal number. But our text property, it always treats it as text. It's a string. So it's saying, kind of like saying ABC times. We can't do this. We can't multiply a text value by a number. So we're going to have to do one more thing. what were we going to have to do with the amount in our text box so that we can actually perform a simple math operation and Visual Studio won't give us an error? Alex? Yeah, we're going to have to convert this. We want to change this value from a string to a number. And then we can do our math with it. So Visual Studio C# has all kinds of methods to convert from one type of data to another. So we're going to have to call the method that's convert to a decimal. So in front of this, I'm going to type convert dot to. There's different sizes of integer. It doesn't really matter which one I pick. We commonly use int. Whoops, actually, no, I guess it's not going to be integer. We need to convert to a decimal because the purchase amount might be $9.99. So we'll put purchase amount.text in round brackets. Okay, it still doesn't like this. Maybe we'll try something else. It's giving us, saying that 0.13 is actually a double. So maybe we'll use double instead as our numeric data type. We'll try to double. And we'll change this to double. So double is another type of number that can hold decimals. We can use that instead. If Visual Studio is asking us for that, that's fine. So an integer can only hold a whole number. Decimal or double will hold parts of whole numbers. So now our error goes away. Now we haven't displayed this value yet. To see if it worked, if our code worked, I'm going to click over here to the left of my line 31. I'm going to put in a breakpoint. What this does is it lets us run our code and then actually look at what's happening in our C# while our application's actually running. So if I click start, we can see what happens. So I'll type in $79.99. And when I click my calculate button, notice my screen gets hidden and this line turns yellow. If I put my mouse over purchase amount.text, Visual Studio actually shows me what's in the box at the time. So I can evaluate what's happening. When I put my mouse over tax, well, tax by default is 0, right? Because our calculation hasn't executed yet. If I want my code to run and I want to go to the next line, if I press the F11 key, my purchase amount.text is still $79.99, but now when I put my mouse over tax, there's my value. Right? It's calculated my tax. And now I continue. So that's good. We didn't get an error, and our tax is actually being calculated. So we've done part 1 of our processing. I better stop my code. So that's processing part 1. We now need to do this. We now have to figure out the total amount of the purchase. So how should we do this?
No, just do double total equals convert to double purchase amount text plus tax.
Yep, that's exactly what we can do. So we're going to create another variable called total. So now we want to take the purchase amount again, convert it to a double so we can do math with it again. So this time, instead of multiplying it by 0.13, we're going to add the tax on. Now, I got a red line here,
Capital T.
right? It says, I don't understand what text written all in lowercase is. Notice here, the text property, it starts with a capital T. So that needs to be a capital T as well. Then my error goes away. So we've done our processing now. We've calculated the tax, we've calculated the total. So we've done our we've got our input, we've calculated our first value, we've calculated our second value. Now we just need to display the two outputs and our program's done.
Okay, let's just do that.
So what should we do for displaying those?
Well, we can use labels.
Yeah, why don't we let's put on 4 more labels. Okay, we'll put on a label over here that says tax, and then we'll put on a second label beside it where we'll print the tax amount. Then we'll put a label below that says total, and 1 more label where we display the total. So I'll open my toolbox back up. So I'm going to drag on 4 labels. 1, 2, 3, and 4. So this one that says label 2, we'll change that to say tax. And that's just an instruction label, like our enter purchase amount. We're not going to change that value. And I'll click on this one here. We'll change that one to say total.
Bracket and like actually put like, you know, dollar signs to show the unit, or should we just assume that you don't? Like this?
We could format it as currency. We won't do that yet. It's a little extra challenge for those of you who this lesson is slow. You can try and see if you can get it formatted as currency. You can also see if you can figure how to get this box to only allow numbers. The other thing actually I'm going to do on my purchase amount, because it's a number, let me just run it right now. Notice when I type, normally when we've got currency, we actually align the numbers to the right of our inputs. We can change our box so that the numbers are on the right side rather than the left side if we want to. So if I click on my purchase amount text box, somewhere in here, down near the bottom, there's a property called text align. If I click on that, I get a little drop down. By default, all text boxes are aligned to the left. I can actually change it so those numbers appear on the right side of the box. So we don't want this to say label 3. We actually, what should our label say? What should these two labels say when the user first loads our screen?
0.
Yeah, they could say 0 or they could even be blank. So I'll put a 0 in here. And we're going to want to change this text, right? When the user clicks the button, we're going to change the text from 0 to whatever our result is. So we should probably give this label a descriptive name, because we're going to have to access it in our C# code. So what should we call this label? That makes sense. What value is it going to show? Yeah, it's going to show the tax. So maybe we'll change that from label 3. I'll change that to be tax. And we'll do the same here with our last label. We may as well call this one total.
I think it's important to differentiate that for both tax and total, just now you put capital T on them. Is it fair to use lowercase tax?
Yes, I use those. Okay, you raise a very good point. If we call them tax and total, Well, it's a bit confusing because we've already created variables called tax and total. Well, there's probably a better way of naming these. And I'm going to show you convention that I use. We want to give them descriptive names. We call this purchase amount. What's a good idea is not only to name it for what it holds, but it's also not a bad idea to give it some indicator as to what kind of control. So I think earlier someone had mentioned we could call the box purchase amount text box. Often we'll use little prefixes to indicate it. So rather than calling this one tax, I'll call it LBL for label. We'll call it LBL tax. So we know that that's a label. And we'll see the benefit of doing this in a minute. So for this one, we'll call it, instead of total, we'll call it LBL total. If you want to call it something else, that's fine. You want to call it label total or total label, that's fine. You have a comment? I saw it. Yeah,
Oh, no, yeah, no, I was just gonna suggest calling it tax.
Well, there's a reason why, and I'll show you in a minute, why using these little prefixes before our objects is useful. Right? Instead of calling, I'll leave this one as purchase amount. Normally, I would call it TXT purchase amount for text box. And for button, I would call it, say, BTN calculate. We'll look at why after, but I'll leave those two alone. And I'll also change the text on my LBL total. I don't want it to say label 5. I want it to say 0. So now when we run our form,
Now we just say tax equals LBL tax.
well, we'll write it. I realize it's almost time for a break. We just need to now add these 2 lines of code to display the tax amount here and the total amount here when the user clicks the button. So we have our amount of tax. So how can we get that value to show up here? We want to replace the 0.
Not 100% sure with this one though. Is it just LBL tax equals tax?
You're very close. Now you'll notice why I like to use those little prefixes. If I type LB, right, because we get the code hints, if all of my labels start with LB, then it's going to show up in this list and be really easy to find. If I called it tax label, I wouldn't see it, the label, right away in my code enter. So let's try that. If I say LBL tax equals tax, right? So there's our tax variable. What's it telling me? It says tax is a variable of type double. LBL tax is a label on our screen. So we can't set them equal, right? We're saying an apple is an orange.
You would have to convert into string.
Okay, well, we need to do 2 things. It's not the label itself. What attribute of the label? Right, we want to set the text property. Not changing the label itself, we're changing the text on our tax label. Okay. Now we still have an error. We can't convert double, so tax is a number, but text has to be a string. So here we did the opposite, right? We took a string and we converted it to a double. Now we have to do the opposite. We have to take a double and convert it to a string. So how do you suppose we would do that?
Convert to the same way we did.
So here we used convert to double to take a string and make it a double. Now we're going to do the opposite. If I hit convert dot, there's our toString. And now take our numeric tax amount, convert it into a string so we can display it in our label. Now there is a shorthand for doing this. Let's run it and see if it works. When we convert things to strings, there's a shorter way of typing it. So let's run this. Now if we run it, there, that's the result we wanted, right? The tax is being calculated and displayed in that label. No, it's not formatted as currency, it's not rounded to 2 decimal places, but our code is working. So the last thing we just have to do is to display the total down here. How would we do that? That's the last step in our program, then we'll take a break. Where do we want to put the total out? In a tax label, in text box? Yeah, in the label we made called LBL total. If I just hit the dot, and again, we'll set the text of this label. Now we could use convert.toString, but I'm going to show you the alternative. We can take our total variable, which is a double, and just call the toString function of C#. So to convert anything to a string, we can just call .toString, and it changes from whatever it is to text. So these are equivalent. If you want to use that one, that's fine. It's more typing. They do the same thing. That's what we want. We've got one simple input, a little bit of processing, and 2 outputs. I realize the conversion from strings to numbers and numbers to strings, that part, if anything on here is confusing you, that's probably the part that's confusing you. But if we don't do this conversion, we can't take text and do math with it. And then we can't take those numbers and put them back as outputs to our user. So we have to do this little trick of moving from text to numbers and then numbers back to text. We have no way around it. Does anybody have any questions about our little calculator, what we've done so far? Does this look very strange to some of you? It should. It's new, right? Most things are going to look strange the first time we do it. Right? But we're going to do this over and over again, and pretty soon it's not going to seem quite so strange.
Is there no way to set it so that the text box that takes the subtotal can only accept an integer, just like with it, or in this case, that's double actually?
Good question.
But just in like a simple form, like
right. If I do this,
double kind of idea.
Yeah, we haven't done anything to prevent this, right? What's going to happen when I click calculate tax, do you think?
You might get more.
Format exception, right? String was not in a correct format. So it can't, when it tries to convert that to a double, it crashes. You can't take ABC and turn that into a number. Doesn't know how to interpret it. So if we wanted to do that, we may be able to do it right through here. Right through the properties, we might be able to control. There may be an option here that will allow us to set that it's a number only, or we may have to do it a different way. We would probably have to do it this way. Actually, I think what we would have to do, I don't know that we could prevent the user from actually typing a number in here, but what could we do in our C# code to make sure that we don't try and do a calculation if they haven't put in a number? Well, I'll let you answer your own question.
As soon as you push the button, you can run a check, and then if it doesn't fit what you want from the user, you can just tell
Right.
the user.
That would be our option. So before a different message to the user. And if it is a number, then we could go ahead and do our processing and calculation. So that's what we'd have to do. We'll leave it for now, but that would be the idea. Okay, it's 10 o'clock, so let's take a 10-minute break here. And when we come back, we'll do another example or two in the next hour. Okay, I don't think we'll have time for the lab in class. And because you guys have another class tonight, which I had forgot about, I will give you probably until maybe tomorrow night to do the lab. Okay, so you won't have to do 2 classes in your lab today. You have tomorrow. Okay, so I'll change the due date on that. So we'll come back in 10 minutes.